Hi, everyone. I'm Jiajun from the University of Edinburgh. The title of my presentation today is Slate Detection in orthophotos of building roof panels. So traditional roof defect documentation relies heavily on human labor now, which requires them to locate individual slates and then specify their defect type. So the overall aim of my PhD is to develop an automated approach for building roof condition monitoring that leverages digital twin principles and remote sensing. And you can see the approach overview on the right. There are two inputs, the structure from motion 3D reconstruction and a digital twin model. And after 3 stages, the detected information, including the defects, is updated in the digital twin. And I have actually presented the study of stage A and B in ISARC of the past 2 years. And the study that I'm presenting today is part of stage C, which is the deterioration and defect detection in segments. And it aims to detect individual slates in orthophotos as the basis for defect detection. So stage A and B realize orthophoto generation and slated area segmentation. And these two pictures are the output of the 2 stages. So the slated area is actually input to stage C, aims to do the defect detection. Now in stage C, we roughly propose 2 methods. The first one is detect individual slates and then classify them in terms of their defect status. A second one is detect defects directly. So this study is the first step of C1, slate detection. So to deal with the problem I just described, we propose 4 methods. And the first one is traditional age detection. The second one is the original SAM segment anything model, which is built based on transformer. And methods 3 and 4 are the hybrid method of method 1 and 2. So I would like to explain the method development by listing the patch processing pipeline. The method 1 is age detection by Canny detector, where we apply the Canny age detector first, then we extract the lines, then the strips, then we calculate the values for each strip, and then we extract the box of each slate and then resize it to better fit the boundary locally. In method 2, we apply the SAM segmentation mask and we extract the largest connected components and apply slight extension because the SAM boxes are systematically too small. In method 3, we use the output of method 1, the bounding boxes, as prompt to the original SAM model, and then do the box extraction and slight extension again. And finally, in the last one, the method 4, age detection by original SAM mask, we simply replace the former traditional Canny age detector with the SAM segmentation mask and follow the rest steps of method 1. So I would like to list the results of 4 methods here to compare. So different colors represent different slate detection performances. And you can see from the table down there that method 1 outperformed the rest 2 with higher mIoU than recall. And apparently method 2 is worse among them all because a lot of components are just connected, making the detected objects too big. So we assume this is because the original SAM model is not sensitive enough to the slate boundary. So in method 3, we upgraded this model by input some bounding boxes, but it's improved a lot, but there are still a lot of false positives and false negatives, which are the blue and the red boxes there. And this indicates that although it's an upgraded model, it's just too sensitive that it even detected this biological growth. You can see these kind of blue and the red boxes gather around these biological growth defects. So to process the orthophotos of panels of any size, we tile the orthophotos into patches of overlapping patches of fixed size, and then we process each patch using the slate detection method I just presented, and then merge them back to the original panel orthophoto. So to robustly merge those results, especially in the overlapping area, we applied a three-step strategy. The first one is we discard the boxes located at patch boundary. And secondly, those boxes whose dimensions are smaller than half the exposure are excluded. And finally, those redundant boxes are removed using the non-maximum suppression. So you can see the merged results here on the complete panel orthophotos. So to obtain the parametric validation results, we manually label the orthophotos where around 4,500 boxes with their defect categories. So now we realize that we might have a real but also interesting dataset to publish, which is also challenging, not only in their geometric features, but also in defect identification, because nowadays they rely heavily on the works experience. So we can finally see the visualized results here. Again, different colors represent different performances. And by comparing method 1 and 4, we can finally now conclude that method 4 performed the best with decent mIoU and recall. And I will explain the idea of non-boundary in the next slide. So let's take a closer look at one of the roof panels. So just as I mentioned before, there are a lot of blue and red boxes gathering around one specific area, which is the biological growth defect. So it interferes with the slate detection method. And those boxes located at the boundary between the panel and the background, their shape is normally irregular, but they are usually not considered in the defect detection process. So the general performance is fine for the current application. So in conclusion, this study focuses on the problem of analyzing traditional slated roof, which is way more challenging than analyzing modern slated roof due to their greater variability and appearance. So we presented an overall approach and 4 methods for slate detection in orthophotos of building roof panels, and the method 4, which is the age detection on the original sand mask, performed the best. However, the performance is not yet good enough for practical use, and there are a few directions where improvements could be made. First of all, the data collection, we definitely need more examples to increase the size and the representativeness of the dataset. And secondly, we could improve the orthophoto generation and the final quality of it. And finally, we need to improve the robustness, especially to the biological growth defect area. So it should also be noted that although we pick method 4 as the best among them all, the rest 3 could still be useful because the roof patterns can be different. For example, slates could be laid not only in a horizontal way, they can be like fish scale patterns. And finally, I would like to place this work in the overall pipeline that we developed for my PhD research. So now we are able to detect the roof components. And now with this research, we can detect these individual slates and in the future, those defects. And we can spatially link them to the 3D digital twin model. And this will enable longitudinal analysis for roof condition monitoring. These are the papers that I referred to. Thank you very much.